Welcome to Unscripted with Jeff Pedowitz. I sit down with remarkable people from very different worlds, security and science, business and medicine, technology and the arts, for honest conversations about AI and where it's taking us. No scripts, no talking points, just what they actually think. I'm Jeff Pedowitz. Let's get into it. Most of the AI conversation lives in software, but my guest today works in concrete and steel. Nicola is a civil engineer and technology executive who has spent more than a decade bringing AI and digital twins to the things that we actually build and live in. Airports, bridges, water systems, including some of the largest infrastructure projects on the planet. And now he's building an AI subsidiary inside a civil engineering firm. So construction and infrastructure are famously among the least digitized industries on Earth, very slow to change and unforgiving when things go wrong. So that's what I actually wanted to get into, what AI actually does once it leaves the screen and has to hold up a bridge. Nico, welcome to Unscripted. Let's get into it.
Thank you, Jeff. It's my honor to be here.
So interesting combination, like so many people I talk to are on the science side, even the business side. You're the really first civil engineer that I've spoken with that combines it. How did you kind of bring these two together?
I think that there is a desperate need nowadays to step up, building the future. Obviously, we hear a lot about building the future, but what does it really mean? We need to combine traditional engineering, when it needs to be slow, safe, and absolutely accommodating every kind of industry. And then on the other hand, we have AI and the technology that is going at light speed, right? So we need to combine the two of those. And I think that being the bridge of these two, I would say words, can be absolutely interesting, fascinating, and extremely challenging.
What do you find the most challenging thing about applying AI to your world?
Great question. So, I used to think back in the days that being the slowest adapter of AI and technology from a broader perspective, I thought that engineering was just resisting the fact that, it's going too fast. I'm not sure. I don't want to overstep. I don't want to overcommit to something that is not fair, or I'm too lazy to change. That was the mindset a while ago. And then suddenly I realized that engineering is much more than that, because if something goes wrong in engineering, people can die. Or, so it has dramatic consequences. Not that writing a code and then, oh, yeah, no, the software doesn't work, and suddenly you can go back and back test or bug and check for bugs. But if you overlook on something that engineering, which is a critical, from an example, like a critical structural foundation, and then you see that you overlook because you're too busy, you trust AI, you over trust AI, and then suddenly, everything goes wrong because you get approved, it doesn't get checked. And so obviously we have like a QA/QC process, quality assurance, quality control. But let's say that the whole system failed, right? So at the end of the day, you're in the construction phase, and then suddenly the building collapses, and then that's gonna be a disaster, that could be avoided, especially now that in 2026, now going back, forensic engineering is gonna have a lot of repercussion on everybody in that specific field.
So did you grow up always wanting to be an engineer, or did you have some different designs?
So my father is a doctor. I always dreamed to be a doctor because I think I have a good attitude. I love people, I love dealing with people and I love helping people. And then suddenly, that's a funny story. When I was 19, when I finished high school, I asked my father, hey, how long does it take for you to become a doctor? Oh, he said, oh, 11 years. I say, oh my God, no, 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 no way, no way, no way, no way. So I decided to go engineering, but I took the freedom to take two masters at the same time, architecture and engineering. So I overlapped the two of them and I squeezed them. And obviously it took longer than 5 years, but now I have two masters. That at least opened the mindset of being a structural, strict like square engineer to something that is have a broader view.
So now it should be obvious to most people, but you're from Italy, right?
Yes. Yes.
Um, so how, as a country, because what we here in the U.S., like we see what our attitudes are pro and for AI. How would you describe your country's attitude towards AI in general?
So there is a lot of controversy. That America advance, Europe regulates, right? So the path to the future I think is bright for both sides, but I think Europe is advancing at a way slower pace because they want to make sure that everything is human focused, which is absolutely correct, but they sometimes tend to over-regulate things. And instead of empowering, for example, engineers like in the US, they try to trap engineers and then they box them against the wall and then they realize, oh no, we need to change it, we need to move. So suddenly they do a U-turn, and then they at the end of the day they lose a lot of time. That's why I prefer what we're doing here.
So, I mean, how do you think they can balance that, right? Regulation and control with innovation?
I think what we're doing at the society, man, is the right thing to do, and we're exactly in the right time to do it.
Well, we debated a lot, right? We talk a lot about the ethics and what should happen. Still unclear, though, right? Both here in the States as well
Yes.
as internationally. I mean, yes, you see certain countries in the EU moving forward with some sets of policy frameworks, but compared to normal technology or governance, I mean, AI is moving much faster than any policy position, right, can keep up with. So, what do you think the right framework is? I mean, how do you keep a balance that applies ethical guidelines, but not necessarily constraints? At the same
Uh,
time, how do you support innovation?
Absolutely. I do believe that we need to always have human in the loop, in every process that we have, because we need to maintain control of everything that is happening. Sometimes we see rogue AI or shadow AI, and then we need to backtrack what it's doing and why it's doing that, and if it was a mistake in the programming or if it was like a deliberate choice, which is going to be very, very interesting from a futuristic perspective, but at the same time can be extremely scary because then it's going to have unregulated choices, and sometimes it's difficult for us humans to understand why it went away. So I think that creating some boundaries and then, for example, having the possibility to do forensic preservation for AI when you can put the AI on a stasis, on a cell, and then investigate what happened in order to avoid this to happen in the future. Obviously, thinking of the worst case scenario, right? 90% is good, 10% is bad, but that 10% can be very bad. So we need to constrain those leashes.
You were just in China, right, about a month ago
Yes,
for
that's
our
correct.
conference. Did you have
Yes.
an opportunity to observe or interact with people and get a perspective on things that China is doing, both
Yes.
better and maybe worse than what we're doing here?
So there is a dramatic difference between us and China. We have the debate. We put human in the center. We want to have little bit is good, little bit is bad. Okay, we always stay between like a very close center. And when I went to China when I went to China, the feedback that I received was there is one way. You like it or you don't like it, there is only one way. And we got the perception that people do not really know that even those working in deep in the trenches on developing AI, machine learning, etc., they do not really see what's happening outside in the planet. They only have one way, which is to beat the US at the end of the day in the AI race, whatever it takes. So that's why I think that what we're doing is extremely, extremely important.
But what's your opinion on that? Is that good, bad, or just different than on how they're
So,
doing it?
so from a I put I try to observe from a very cold logic perspective, being an engineer. So I love the pace that they're doing things. It's astonishing. It's fast. Is they run. We're walking. I don't say crawling. Europe is crawling. We are walking. They are running, like running on a horse. So it's fast. So I appreciated what they're doing. For example, we saw some robots and it's incredible. You saw the autonomous vehicle, incredible. And we're still debating: is it safe? Is it not? What is going to be the integration with the traditional driver? Are they going to accept it? What is the impact on the community? We try to get the feedback. We try to convince them, and that's why education in my opinion, and I know you agree, is the key to move forward. To try to show guys this is safe. We can guarantee that this is safer than any human activity, for example, autonomous driving, and therefore we can move. But until we overcome this kind of impasse, that will never happen.
If you look at our educational system, I mean, there's a lot of things that are good about it, but then there's a lot of things that are broken about it. I mean, for the amount of money that we put into education, the outcomes still are not there. We have outdated standards, outdated ways of moving, and there still is wide disagreement amongst our school systems and districts on how to even use AI, let alone teach students how to use it. I mean, they're still teaching marketing principles from when I was in school, and that was a long time ago. So how do you think we need to approach it? I mean, because it's not a one simple answer, right? But we do need to overhaul our educational system.
That is correct, and great question. And I believe that the only way will be to have, like we're trying to do, to have a few pilot projects to showcase to the teacher, and the teacher, I mean the dean, director, everybody in the academic role, to show them that they can take advantage of AI to empower them to achieve more from the student that they influence. If you think, from a philosophical perspective, those ages, those years are foundational for your whole life, right? So I went through engineering, I went through architecture, I went to high school, yada yada yada. And at the end of the day, you say, how much of what I learn I'm actually using, how much of that is valuable for me I spent like 20 years, 23 years learning things. And then out of that, what did I get? Then everything like technology, I never learned anything about technology or engineering. They give you the mindset, which I appreciate, but that's a stretch. It doesn't teach you the mindset. The mindset cannot be taught. The mindset can be like every individual has their own mindset. So you can say, hey, this is the way, but then every individual have to have their own path. But nevertheless, I think that AI is going to empower us, empower the teacher in this case, or the academy, to get the most out of kids, because a teacher does not have the time to understand exactly what a kid will excel in, or a student. AI can do that. An agent can focus, can study, can know everything about you, and then can choose the thing that you like the most, and then it's going to give you everything that a teacher cannot do. So I think, overcoming this barrier from an educational perspective, when we showcase in 1, 2, 3, 4 schools that this works, and then we can go to the Department of Education, to the State Department, and then we can go to the National Department of Education. Then that's where it's going to have the flip on this side.
What about just the outright apathy and resistance from the Gen Z crowd, which is almost universally rejecting AI? And, I can get on some reasons why they feel that way, but, Pandora's box is already open, but there seems to be this huge amount of resistance. So what do you think we need to do there?
I think they see AI as a threat and as a lack of humanity. I think that obviously this is a broad statement, and I do not want to jump into judgment, which I'm not absolutely entitled to do that. But from a perspective, an engineering perspective, I am very surprised when I receive kids or email or LinkedIn comment, or request, and say, hey, I saw what you're doing, super cool. I feel unsure. I do not know if this is the right path. I feel threatened because suddenly, I realize that I'm not going to have a job in the future. And so there is a lot of fear, but I think that magic is on the other side of fear. So you need to overcome this moment that is gonna stick you down, and then get to a different level. And I think that kids, being in this uncertainty, being that everything is changing so fast, there is no what we have, like for example, what we have as a foundational values for my parents. They will always be there. They are there. They were there. They will always be there. Same for you. The family perspective. And now kids are thrown out in the street, or they can make their own choices very young, and they can influence their life in a way that they may not even be prepared to. So I think AI is adding an extra weight, like a gigantic weight on their shoulder, and they are not ready to hold it yet.
Yeah, I think that's a good perspective. Well, not just that AI, we see even social channels changing, right? We're moving from social media to social interest, social engagement. There's almost a concentration now on, say, TikTok and Instagram,
Yes.
and almost a rejection of many of the other social platforms, at least by the younger age anyway. I think, people like
Yes.
us are using a few more. So I think that has some interesting repercussions. Do you think that AI will be used in new ways to have different ways of collaboration? Will we see new platforms, new channels that people will use in part because of AI?
I would say, again, from an engineering code perspective, I would hope so. Obviously keeping in mind that we need to do everything we like as the one creating this possibility for the younger generation. We need to protect them from something that they will not even know. That can be an overstatement, but I think that we have a huge responsibility nowadays, because otherwise, we can drive humanity to a place that we don't want humanity to be in the near future. And the generation is there. So if we make the wrong choice today, it's going to be very difficult to fix it in the future. Certainly, again, from a code perspective, I would hope so, because it's going to empower us to do so much more, to touch things that we were not supposed to touch, or we were never capable of touching back in the days. I wish I was 18 today with all the capabilities that we have today.
I miss the carefree days of being 18 and not having so much responsibility. Those were good
Yeah,
times.
man. So every day you can say, "Oh my God."
Well, as they say, youth is wasted on the young, right? So if we could only go back in time, um,
Yes.
your work's really
Well,
cool.
maybe
I
we
think.
can. Soon with quantum computing, we may be able to
Yes,
do that.
yes, quantum
Just throwing it
absolutely
out.
do that for sure.
Yes. Yes.
I think about your work, and the first thing that comes to mind is that game SimCity. Where I
Yes.
ever play that. So, was that like a precursor to what you're doing now with digital twins for airports and bridges?
So if you allow me, I would like to explain maybe to the audience what a digital twin is. So a digital twin is nevertheless of a replica of an existing physical asset. For example, if we're talking about the construction, a digital twin of a building can be the same building but in a virtual environment, right? So let's say we have a skyscraper, we have the physical skyscraper, and then we have the same replica. The digital twin is the bridge between one and the other, which means if something happened in the real skyscraper, it's already happening in the digital twin. Why? Because we have sensors and all the technology to capture the event and then replicate the event in the digital twin. The advantage of it, obviously, is that we can simulate so much more in the digital twin without affecting the real one. So we can simulate forecast, weather pattern, hurricanes, tornadoes, earthquakes, explosion, fire, whatever you want. And so this will come at a minimum cost, because obviously you don't have to destroy anything
Mhm.
physically. You just have to simulate what will happen if that happens.
But with engineering principles, right? Wouldn't you know that anyway from a mathematical standpoint? I mean, you're calculating tensile strength. You're doing weight ratios, all those things. Um, is this more of a visualization exercise versus just a straight math one?
So at the beginning, yes, the beginning will absolutely to be just a visualization of what's happening in the real planet, in the real building. But then it goes beyond, because the fact that you can recreate the whole building with the physical properties. So, for example, if you create a steel column, it has the same physical properties as the real steel column, right? So if you say, hey, let me put like 100 tons on that physical column, obviously the one in the reality may collapse, and the one in the virtual environment collapse. So we say, okay, we need to strengthen it, make it stronger. So you can make so many simulations on that. So you can forecast anything that may or may not happen. And this obviously allow us to do design variation, or we also have we just discussed about the 3D, right? Now you can also add another dimension, which is the fourth dimension, which is time, right? So you can showcase how the building will age in time. So 50 years from now, based on the change of the dedication. For example, let's say the building is a residential. Now you divide in 20 years, it's going to become half offices and half residential. 10 years later, it's going to become commercial, office, and residential. So you can simulate all these events, and then you can check the occupancy rate. You can potentially empower AI to be the one making the decision to check the air conditioning. So the objective of AI is save as much energy as possible. And now AI understand the human pattern. So they come in at 8 a.m. and they leave at 6 p.m., right? So in that moment, you need to have a constant flow of air, but you do not turn it on at 6 a.m. because it's going to take so long to cool the building. You turn it on a little bit earlier. And then at the same time, you can either switch it down or leave it on, depending on the pattern, depending on the weather outside and the temperature and the humidity. So this is just one example for one indicator.
Well, where is this being actively used today, and where is it still a bit more of a pitch or a pipe dream?
So a pitch everywhere. Being used in a real application, for example, for vibration of bridges. Some of the biggest bridges, the biggest project that I've been working on, they have vibration pattern. So when you have a load coming, then you understand the traffic pattern, and then you can simulate, hey, let's say that an accident happened on the bridge. So now you have every car possible is going to be stuck on the bridge. Is the bridge sufficiently strong to resist that amount of load that was not unexpected? Obviously, in the engineering world, we do a lot of simulation on this to happen. So you always design for the worst case scenario, and then you apply a safety factor. The safety factor depends on the area in the planet where you are, depending on, I'm going to have a hurricane tomorrow. Okay, so you need to have the safety factor in account. But nevertheless, that's always an exaggeration of what it needs to be, because it's an approximation, because we will never know exactly how many variables we have on the bridge. AI per se, possibly quantum computing, can absolutely have all the variables in real time. So it can compute the real worst case scenario, which means that if the deck of the bridge was supposed to be, and give you a number, 20 feet, now based on the new design, it's going to be 15 feet. So you save 5 feet of material. So you save a lot of money in the capex, in the capital expense.
So is there a project that you've worked on recently where, because you used the digital twin, it changed the outcome of how the design was actually built?
So yes, absolutely. So for example, I was in Canada working on a project that is called the Muskrat Falls hydroelectric project. It's one of the biggest dam in North America. And what we used was the 4D simulation, to simulate the pouring of the different concrete pours. And this way, we were able to work with the planning department to showcase that we can only pour that much concrete at the same time, or we can redistribute the trucks. Imagine a dam was like a huge project, it was $2.2 billion project. So obviously you have multiple working areas, you have multiple cranes, you have multiple everything, right? So it's very difficult to coordinate everything. And the virtual environment, the digital twin, was allowing us to maximize the efficiency and minimize the risk. Because obviously if you don't know, oh, this crane is moving over this area, then suddenly you're putting the worker under that area in a risk, because obviously we avoided a lot of mistakes in that, and major mistakes.
So is this software that your company has developed, or are you using a third-party platform?
So we are using a third-party platform. We are partnering with different software houses, and they are working with us to develop the best, the safest way to design this kind of project, right? So what we're trying to do is to keep everything from a human perspective, obviously, and then minimize the risk is number one. Safety obviously is number one, and then obviously if you can minimize the time of the construction. We have a bridge. I live in Miami. I'm Italian, but I live in Miami. In Miami, there is a huge bridge being built, and it's 9 years in delay. So that's a long time for a delay for a major infrastructure bridge, which all the people complaining, all the delays, all the money spent, etc. yada yada yada. As you can imagine.
Well, in addition to your engineering side, you do a lot of speaking and writing about the human side of AI, and you talk about empathetic AI.
Yes.
Within the context of what you do, though, in infrastructure, where does that play a role?
I believe that one other thing that we need to take into account, as I was mentioning to you earlier, we need to have the human to be the lead, specifically in our industry for engineering, right? So I believe that what AI is going to do for us is going to empower us to do much more. But I believe that we need to keep human in the center. That's why I believe that AI should serve humans. We need to, I strongly believe that we need to protect AI, because I think this is going to be the only differentiator. It's going to be bigger than the fourth industrial revolution that we have before us, right? I think this is going to allow us to become an interstellar species, to unlock something that was locked for thousands and thousands, millions of years. And so we need to protect it. But at the same time, we need to be sure that it protects us. So the way that I see moving forward is that we're going to have humanity and AI, and we're going to merge into one entity, So we're going to get the maximum of one side, and we're going to get the maximum of the other side. I think we need to design, when I discuss about empathetic AI, we need to design systems that understand the intersection of human behavior. So not maximizing profit, but maximizing humans, so get the most out of what we are, get the most out of what we can do. So human-centric priority,
We reflect back on construction. I mean, there have been massive projects that go back thousands of years, right? Whether you look at the pyramids, the Colosseum, some other areas that took significant feats of engineering. Now we have the Industrial Revolution, right? We can start going up higher because of engineering, steel, materials, etc. Yep. That industry is largely, for the most part, hasn't changed dramatically in the last 100 years, although we're getting into more environmentally friendly systems and things that happen inside the buildings. What do you see AI doing for this industry in the next 50 to 100 years that we have not been able to achieve in the last 100?
I think it will show us a different way. So obviously now AI, is only emulating what humans could do because it's being trained on human data. But I believe that when we come to the point where AI starts thinking on its own, and AI can be identified as an entity on its own, I think that that's going to be the turning point where we're going to excel at our capacity. For example, we understand gravity to a limit. For example, gravity is the biggest force in the universe. Is the one keeping everything connected, right? If we can understand gravity, maybe there is a way that we can turn around gravity, that we can play with gravity. Suddenly, I'm pretty sure you've seen the movie Avatar. Now we have floating mountains because we understand how to make mountains float. Why not? I think it's a crazy idea, but I think it's worth exploring. If we don't push the limit, we will never know which limits we have. And I don't want to believe that we are done. I love the planet. I'm all for protecting it, but I think we are done to go beyond. I think we can challenge our limits, and I think it's mind blowing. What we're doing, I think, is mind blowing. But what is even more mind blowing to me is that people are accommodating. Say, yeah, that's it, And they say, no, that's not. There is so much more. So I do not have an answer for you.
Physicists would have a field day with that,
I know.
floating mountains, floating buildings.
We'll see. Maybe another planet is the way,
Yeah, I mean, if you remember at our meeting a couple months back, one of the generals was talking about autonomous drones. We had quite a vigorous debate over the role of AI. As it relates to construction and engineering, though, would you let AI sign off on a design without human involvement? Because if there's a mistake, right, a bridge collapses, a building collapses, that kills a lot of people. So where would you say, yes, I'll let AI autonomously make that decision, and where would I have a human being do it?
I think so. So that's an interesting story for it. So in the US, the PE, the professional engineer, only started existing about 100 years ago. It started in 1916, if I'm not mistaken, or 19 around the 1920s, right? Before that, buildings were built and people was liable for that. So now the PE, the professional engineer, or the UR, the engineer of record, is the one responsible for stamping and signing the drawings. Before that, there was the response to the master architect, the master builder, etc., etc. I believe that one of the biggest discussion that we're having or that I hear at conferences is liability on AI. Now AI cannot be liable because they say, "Oh, I use this AI to design my building, and suddenly the building collapsed." Okay, who is liable? The programmer of the AI, the chief, the CEO of that specific AI. Who's going to be liable? And there's no answer, right? But what happened is the fact that I think we are evolving very in a super fast, and I think that boundaries is getting very very gray. It was like a net line in the past, and now it's getting grayish. And I think in the future, possibly AI can design things better than us. For now, as I was mentioning before, there is the absolute need to have human in the lead, not in the loop for this kind of industry, because we need to make sure that we do not have a collapse in the center of a major city, and then suddenly, you kill a lot of people, you disrupt infrastructure, you disrupt everything, and then nobody's liable anymore, right? But in the future, where this AI is gonna get more and more relevant and capable, I think that that's a discussion that we need to have. For example, autonomous vehicle. If a vehicle crashes today, if I'm crashing today, I'm liable. If AI, a Waymo or any other autonomous vehicle is driving on its own and crashes, we need to apply the forensic preservation I was mentioning, put in a stasis and investigate what went wrong. You know, I saw autonomous vehicle swerving in a fraction of a second. The human response is 1.5 seconds. The average, Formula One pilot is faster, but the average is 1.5. So if I'm driving and then suddenly a kid jumps out of the curb and I don't see it, boom, and then I'm liable. But I saw AI swerving super fast, so I see that as an extreme advantage and value added to our safety and not a detrimental to our driving capabilities.
Provided that it doesn't overreact. I mean, there have been some stories, right, with Teslas crashing into houses. The SpaceX satellite just crashed into the moon.
Yes. Yes.
So I wouldn't say it's foolproof yet. There's room for, but yes, I think the potential is there. But I think it's understandable, right? I mean, as a human, you're like, hey, an AI built this bridge, an AI built this building. Some of us would think it was cool, and others would be sort of tiptoeing. Okay, is it
exactly?
Safe? I don't know if you've been out to the Grand Canyon. They have that glass platform
you saw
that goes out.
Exactly.
Yeah,
the edge. Yes.
For a lot of people, it freaks them out. Because it's just like
Yes.
you're Yes. So I think it's there's always going to be that balance, right?
Absolutely. But for example, did you see, if I may, did you see the fascinating story of surgery, from a surgeon in Brazil or vice versa? I don't remember exactly. But then they practiced surgery with goggles, with a robot doing surgery on the other side of the planet. Mind blowing, and then the hole was like a teeny tiny hole. The recovery was super fast and boom, done, perfect. So even though you said that you have a human surgeon, on the other hand, you may have in the future a AI surgeon, which has pinpoint exactly on the root cause of what's happening to you, and then you're safe, you're good.
Well,
Success rate
96%. Been
exactly.
around now for about a decade, and it's getting better all the time. To your point,
now
it's still a human behind the robot, but the precision ability for the tools to be able to make the minimal incision possible, and to go in and very precisely do it versus completely always opening up the patient, right, doing all these things. So yes, I think there's definitely a lot of potential there. It's always weighing both of them off. What do you think? As it relates to the physical world, though, what do you think people typically get wrong about applying AI to it?
So I think we're just at the verge of physical AI, where AI is taking actual shape, for lack of a better word, in our physical world. And I see, you have robots, you have different kind of robots, and they can perform different tasks. I think that we need to be uh, I think it's fascinating because obviously you see combat robot, like you mentioned drones, that's a fascinating story, that's powerful, absolutely powerful. They can see things that we cannot even see. They're gonna be awake 24/7. They're gonna be always top performing. We get tired, we lose control, we fall asleep, etc., etc. We need to. I think it's changing dramatically the way that we perceive things, and obviously with a sensor, infrared sensor, they can go above and beyond what our perception of the world is. Some companies, they want to recreate a digital twin of the planet to showcase the effect of weather patterns on us, and maybe in the future we can change this weather pattern, right, to maximize, to eliminate hurricane, eliminate earthquake, and so on. Like in the last few weeks you saw earthquakes everywhere, right? Maybe
Hmm.
we can understand the route, maybe we can interact with that route, right? So we can save more humans in the future, and that can only happen with physical AI. So that's why I believe that we need to be careful, obviously, but I think it's gonna be another step toward the future.
So you're in construction and you also speak a lot about the human side. With all this AI, it needs so much power, it needs so much data centers. So data centers are in themselves a civil engineering infrastructure
Yes.
project.
Yes.
How do you sort of reconcile that balance? It's your profession to actually help build some of these things, and then on the other side, you argue and you understand the impact. So where do you come out on all that?
I believe that we will change the way that we perceive. I went to a lot of conference, and a lot of people ask, "Oh, AI is killing the planet. It sucks so much energy, sucks so much water, etc., etc." I say, first of all, guys, water does not disappear. It goes in AI, transforms into vapor, goes up, comes down as rain, so it doesn't disappear. There's no way that. Like the foundational equation of mass, mass stays there. You transform mass, but it's still same mass. So it doesn't disappear. We're not losing 30 million gallons of water. No, we're just changing the shape, and then it's going to come down as rain anyway. So that's one. And then I appreciate so much when Jensen Huang, the founder of NVIDIA, he mentioned, that AI used 4%. It was a couple of months ago, on an interview at the CGT. He said, "Oh, AI uses 4% of the energy in the planet, which is a lot, obviously." But he said, "I'm not worried about the 4% because that's maximum efficiency. I'm worried about the 96 that he's not using, because that's when you can save. Let's say that AI is gonna be able to calculate, like I was mentioning to you with the digital twin. You drive down Miami downtown at night at 2 a.m. Every office is turned on, shining, brilliant. You say, why? What is the reason for that? Who cares? I'm looking at the sign at the top of the building. I say, who cares? To me, give me a terrible perspective of the company because it's wasting energy that is the need. Nobody's, oh, wow, I have a skyscraper on all night. What is the purpose of that? So if AI can, okay, there is nobody in the building, switch off everything, like I was mentioning, that is a saving on itself. And then for a data center, what if we allow AI to design its own data center? What if I allow AI to maximize the data center efficiency? So for example, we have water cooling. Now we can design a new fluid to cool the chips and the cooling
Hmm.
tower in a different way. What if we design a way that we can, or a new material? We use AI to design to create new material, to create new combination of steel. So we can use a lot of it on the back end that we don't even know that we can do, because we are so focused on the traditional way of engineering that this is way beyond our thinking capabilities.
Yeah, I mean, if you think about, right, the arch was probably one of the single greatest architectural innovations that's withstood the test of time. So, what new principle right? Could we
Correct.
potentially come up with? So, I think when I think about building, I mean, we can look to Dubai, right, which is an inspiration. Now, we all can't tear up everything and rebuild every 5 years, but that's an example of everything is modern, gleaming, beautiful. The rest of the world, not so much, right? We have this aging, crumbling
Yes.
infrastructure, roads, bridges, like all kinds of issues. So, I'm not saying we can become Dubai, but how could we use AI to really level up, right? And help. It's a huge problem.
And that goes exactly back to what we were discussing before, on the digital twin. If we can embed digital twin in every piece of infrastructure, digital twin is very costly efficient, because the investment at the beginning is very minimal. You just have to recreate the building with a fidelity close enough. We can always have a tolerance, but close enough to replicate the behavior of the building per se, right? As you mentioned, we cannot tear up everything and build new. So what we can do, we can embed IoT, which is Internet of Things sensor in every building, so we can monitor the building. This will allow us to prolong the life of a bridge, which usually have 50-year span, to 100 years, which means doubling the span, the life cycle. How, why we can do that now? Because, oh, sorry, why we can do that now? Because now we can forecast events before they happen. So instead of doing random cyclical maintenance, we only intervene when we define the tolerance level at the very bottom of the tolerance level. So let's say, hey, you have a warning sign, and then it goes yellow. I'm oversimplifying things, but yellow, orange, and red. You never want to go to red, but then you have green is good, yellow is okay, worth checking, and then orange intervene now. So when we get to yellow, we can send a team and check, yeah, everything is okay, and fix it. So if we stitch a sock when you have one hole is a lot cheaper than stitching the sock when you have plenty of holes, right? So if we intervene early, now we can fix the building and then extend the life cycle. I wouldn't say endlessly because that's obviously impossible, but a long time. So we can save so much more money that we can reinvest in this. And obviously we have, like, obviously I'm from Europe, you have all this beautiful architectural creation. You don't want to tear them down, man. That's our
Right.
history.
It's a balance, yeah, but you definitely want to preserve it so that future
Yes,
generations can enjoy it. At the same time,
correct.
finding that balance, modernizing it without changing its ambiance and
Exactly.
its architectural beauty, which is always an
Exactly.
ongoing challenge, right? As populations change and people have different needs as society
Mhm.
evolves. So, what would you predict for your profession over the next 5 or 10 years? What's going to change?
I believe that we have a common motto in engineering, which says that if you do not stay up to date with technology, it's gonna be very uh, tough for you to survive in the near future. But I do believe that we have more opportunities than threats, So if we are able and capable to embedding technology in a proper way, the way we do stuff, I think it's gonna help develop the humanity per se to a different level. It's gonna accompany us to a different level. Um, so yeah, I love where we are. I think we're in the most exciting time of human history. I think we can unlock things in our lifetime, which was impossible in the past, So I'm absolutely thrilled to be here.
As always, my friend, it's always so much fun, and we'll have you back again soon.
Thank you so much, Jeff. It was an honor to be here. Thank you so much.
Nico, thank you for being on Unscripted.
Thank you for inviting me.